The first generally applicable technique that we're going to talk about is a simple but important one called rejection. This is covered, the mathematical foundations of this are covered in DeVroy's book. And the idea is very simple. We generate a random object and we'll just reject it if it doesn't have the specified property that we're looking for. And we'll continue this process until we find one that does have the property. So here's a very simple example. Let's say we're looking for strings that have no occurrence of 2 consecutive zeros. Just generate a string. Well, that one has 2 consecutive zeros right at the beginning, so we reject it. Generate another one. And keep going in that way. We find 2 consecutive zeros in the strings that we generate. And after a while, we get to one that has no occurrence of 2 consecutive zeros, and we accept that. That's the use of rejection for the combinatorial class of a random string with no 0, 0. And it's going to uniformly generate a string in this class. That's what the basic work in DeVroy will tell us. Here's random mapping of 500 nodes with at least 4 cycles. We generate one, it's only got 3 cycles, so we reject it. Generate another one, again, it's only got 3 cycles, so we reject it. Generate another one, this one's got at least 4 cycles, so we can accept it. Very simple process covering something very complex. We have no way to have an intuition of how long the process is going to take, and that's definitely one of the problems. So let's look at the problem of, say, generating random bit strings with long runs. The code for this is very simple. We generate the string, look if it has p consecutive zeros, and reject and try again. And this is extremely simple code. We just go through and make an array with a random string, and then we go and look to see if it's got p consecutive zeros. And if it does, then we reject and we continue until we get through without p consecutive zeros. Couldn't be simpler amount of code. And say we're looking for strings of length 50 with no 4 consecutive zeros. In this case, you get one right away. If we look for a string of length 50 without any occurrence of 3 consecutive zeros, it takes more trials, takes more time. Those are less likely. And if we look for a string of length 50 without any occurrence of 2 consecutive zeros, it's a little bit of a problem. It's 50,000 trials. And generally, that's a problem with the rejection method. We might have to reject a very large number of attempts before finding a desired object. Here's, say, strings of length 100 with no occurrence of 4 consecutive zeros. 69 trials, we get one. That's nice. If we go for 200, it's 600 trials. If we go for 300, it's 1,200 trials, still pretty good. But then in this case, it's 5 million trials to find a string of length 400 with no occurrence of 4 consecutive zeros. And in this case, we actually have the analysis that helps us understand what's going on. We studied this in Lecture 8 in analysis of algorithms. We can calculate the probability that an n-bit string has no run of 4 zeros, and that's about 0.96328 to the n. And if you take n big enough, that number gets pretty small. So it's absolutely a fundamental problem. So rejection method is good to a point, but the more we restrict the characteristics of the class that we're looking for, the longer it's going to take to find a big instance in that class. There is one improvement called anticipated rejection that'll turn out to be important later, and that is we don't have to necessarily generate the whole object. For example, in this case, say we're looking for a 30-bit string with no occurrence of three consecutive zeros. We just have to generate until we find 3 consecutive zeros and then reject. We don't have to generate the rest of the string. And actually, if we're looking for a 100-bit string, this thing would look the same. go on further, but it looked the same up to this point. And in fact, from lecture 8, we know that you only need to look at 14 bits on the average, no matter how long it's going. So that saves a factor of the size of the object, which will turn out to be important later on. So there's many other ways to cope with this cost that have been studied. We're going to stop our discussion of rejection at this point so that we can cover many more powerful ideas in the next 2 sections.